So I have this data set here. Just for a second, we should probably define data for you. Data is anything. This is a data set because it's a list of numbers, but a list of any kind of values is a data set. For example, your grades is a data set. A, B, C, D, E, whatever grades people give you, that's a data set, even though it's not numbers. The comments on your grade, you have some teachers that make a comment in every column on the sheet. That list of comments is a data set. Data is not just numbers, and a lot of people believe that. But right now we will be working with numbers. We're working with temperature in degrees Celsius versus ice cream sales. Like the title of this video says, we're talking about correlation between sets of data. Correlation. And I should get something darker out. Correlation. Between sets of numbers. The basic meaning of correlation has to do with its kind of root word, relation. Okay? We're looking for, in data, a lot of times we're looking for relationships between data sets. I'll use this data set to create what we call a scatter plot. And in a later video I'll use the same data set to create what's called a correlation coefficient. In this video I'll explain what both of those are. But for now, let's start by taking this data set, talking about it for a minute, and then going forward with our scatter plot. Like I said, this is the temperature Celsius versus ice cream sales. Now you would think that there's some kind of relationship between how hot it is and the sales of ice cream in a given area. And so these people went out and gathered information and said, well, let's go to this town and this town and this town and this town, and we'll take a temperature, and then we'll go out and we'll gather information on the ice cream sales in the area, daily ice cream sales in the area. And this is the data set that they came up with. By the way, this comes from www.mathisfun.com. Just so you know where that came from, and there's a lot of good stuff on there too. So that's a resource you can use as you study statistics as well. So on to creating a scatter plot of this data set. Now what you see here is just a basic piece of graph paper with one axis, the x-axis, as labeled as temperature, and the other axis, the y-axis, labeled with sales. Doesn't matter which axis you use, it will show the correlation regardless if there is one. Now it may seem really weird that I'm using all this technology and I'm using just a piece of graph paper and doing this set by hand. But the reason I'm doing it, and the reason this is valuable to do by hand, is because you can't understand everything that goes into creating a correlation graph, creating a scatter plot, unless you do it by hand. And you'll see many things that I teach you as I create this thing that you wouldn't learn if all you did was type the data into something like Excel and clicked on create a scatter plot. Okay? There's a deeper relationship between things than just the Excel program. Besides the fact that somebody had to create that Excel program and they had to understand the deeper relationships, and so it would be wise to learn all of the intricacies. It's kind of like when I went and fixed my truck. I could say I know how a truck works. You turn the key, push on the gas, and it moves. But really, until you've dug into an engine, you don't really know how a truck works, and even then it takes years. So let's dig into this engine we call a scatter plot. If we look at the data, I'm not sure how to label my temperature axis yet. But if I look at this, I look for the lowest number. This is where range comes in. What's the lowest number? Let's see, 11.9. Let's write that down. 11.9. I look for the highest number, and that is 25.1. And now I look for the difference between those two. Yeah, I wrote them upside down. That's easy enough to fix. 13.2 is the total difference. So I need to have a range of 13.2 across this paper. It looks like I could do every other one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.2. That's good enough to serve our purposes. So I'm going to start at 11. Right here. We'll call 11. We'll actually start at 10 and then go 11, 12, 6. So that simple exercise of looking closely at the data set, finding the range, the smallest to the largest, subtracting the two from each other so we know how much space we need on our graph, and then counting out that space gave us the ability to put a correct span of numbers on our graph. If we hadn't done that and we just started labeling, our graph wouldn't be as effective. Excel does that automatically for us, but I want you to see what happens underneath. The next data set we're looking at is these ice cream sales. And if we look at that, let's see, our lowest number is 185. Our highest number is 614. Wow, that's a huge range of ice cream sales. And our range is 439. So I somehow have to divide 439 into chunks. And I have 1, 2, 3, 4, 5, 7, we'll call it 28 sections. Let's see what that comes out to be. 439 divided by 28. When am I ever going to use division? I know we have calculators for that. And here's our calculator. So we go 439 divided by 28, and I get 15.67. It's not a very round number, is it? But if I make each square represent, say, 20, then it won't go all the way to the top of the graph, but it will help. It's a better spread than if I tried 10 and it didn't work, right? So let's try 20 on each square and go from there. And I need to start at, let's see, our lowest, about 180. So let's start at 180. Can you start graphs at numbers besides 0? Is that very good? Sure it is. In fact, some statisticians are very good at starting graphs at places that make the graph look better or worse than it actually is. $100, 620, and my highest is 614, so that should be just a perfect graph to use. Now, if you don't take the 2 or 3 minutes it takes to do that, and to do this little bit of math, then you will find yourself wasting paper and a lot of time trying to make a graph. So take the time to do that before you jump into graphing anything. Next, to do a scatter plot, you need 2 sets of data. There you go, 2 sets of data, temperature and ice cream sales. And what you do is you look at these sets of data as though they are X and Y values. All right. You'll notice I have the x-axis right here labeled temperature. So let's just go just like this on our sheet, X and Y. All right. And we're going to use this as though it's a set of coordinates. The X coordinate on this one, for instance, is 14.2. So right about there. And the Y coordinate is 215. So at 14.2, I go up 215, which is right about here. And I put a little dot. Easy enough. Now I could label that, but it'll make the graph really messy with all of these data points. And now I'm going to label each of these, and I'm going to figure out how to fast forward this thing so that you can watch it in speedy motion. And there we have our scatter plot of ice cream temperature sales versus ice cream temperature versus ice cream sales. Now you'll notice a pattern on this thing. It looks like almost linear. Okay, now it's not perfectly linear. We don't see a line like when you're graphing a line. Remember learning how to graph lines? It's not perfectly linear, but it is linear. In fact, you could draw right now, just playing around, you could come in here and kind of draw a line of fit, where you just kind of make a little guesstimate and say, you know, it looks about like if I have all these data points averaged out, it would create a line that goes through there, or it might be more like here. And there's actually an actual line of best fit that you can calculate. I just guesstimated one really quick. And if I want to say, gosh, if the temperature is 29 degrees Celsius up here, where would ice cream sales be? Well, we could follow our line of best fit up here and think, well, it would be, I don't know, 620, 640, 640, 660, 680. You might make $700 in ice cream sales. Okay, clear up in here. And so you can start to get information based on what you have about future events or other things that you might need. So this would be a good chart to look at for ice cream vendors, for where they want to open or when they want to open their stores, because if sales aren't high enough, they don't want to open it in the spring. They want to wait to open it in the summer so that their sales are high enough for them to make money. So that's essentially how you create a scatter plot and how you look to see if something is correlated.